Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Internal X Sum Yin Yang by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means place a single digit in every cell from the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have yin yang, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected, and no 2x2 area is fully shaded or fully unshaded. So, as an example of yin yang shading, we could have something. Whoops, geez. We could also mess up. Well, we definitely messed up there. I don't know what's going on. My mouse control is not doing very well right now. But we could have shading here, right? So this would be shaded and the rest would be unshaded. And the shaded cells all form a contiguous region, which is all orthogonally connected, which means that if you try to go from any cell in the shaded region, you could go to any other cell in the shaded region, staying within the shaded region just by going through edges. So this is a valid example of yin-yang shading, also because there is no 2x2 area that is fully shaded or fully unshaded. Or in other words, every 2x2 area has to have at least one shaded cell and one unshaded cell. So this works because of how that scenario works. What would not work is something like this. Because this, if you try to go from any of these unshaded cells to these unshaded cells, you cannot stay within that region just by going through edges, right? You would have to cross by going through a border or a corner here to connect using just unshaded cells. And this would not work because, actually this wouldn't work anyways, because this 2x2 area, well, now this 2x2 area is all unshaded. And we have to have at least one shaded cell and one unshaded cell in every 2x2 square, essentially, in this grid. So that's how yin-yang works. We also have small numbers in the corners of cells are internal X-sum clues. And the digit in a with a clue, the digit in a cell with a clue gives the total number of cells, including itself, of the same shading as itself seen in all horizontal and vertical directions. Combined. So cells of the opposite shading block vision. Those cells sum to the number given in by the clue, and digits may repeat within a sum if allowed by other rules. So this digit, if this were essentially the shading, this would say that all the unshaded cells must that it sees vertically and horizontally, and it's blocked by shaded cells here again, would have to add up to 43. So it would be these 8 unshaded cells then would add up to 43. This cell says that all the shaded cells it sees horizontally and vertically, and it would see all of these because there's no unshaded cells. That blocks view, but it would not see any other cells vertically because it's blocked by the unshaded cells here. So it would say that all of these cells must add up to 5. This says that all the shaded cells add up to 45, and this says all the shaded cells here add up to 45, which obviously is going to be problematic. This says all these cells would add up to 26. This would say that all of these cells and all of these cells add up to 46. because it sees all of those cells. And again, I think it's supposed to see itself too. So this counts once, I believe, right? Yeah, because it's all gives the total, the digit in a cell gives a total number of cells. Oh, okay. Apologies. I didn't completely read that correctly. So the digit in the cell tells you the total number of cells, including itself, of the same shading as itself, seen in all directions. So the digit in the cell, if this were the valid shading, this would be 8, and this would be 8. Because this sees 8 cells in that direction. This sees 8 cells in that direction. This also would be 8. This would be 8. Basically, all of these would be 8. This would have to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this would have to be 16 if this were actually valid, but obviously it's not. And then the sum of those digits that it does see sum to this number in the upper left-hand corner. So this would be 8. This would be 8. If that were the case. All of these would be 8, essentially, because they see 8 digits except for that, which sees 16. Anyways, that's how the internal xsums clues work. And obviously, okay, so what happened? Let's try to draw something different. The problem is it's hard to draw yin-yangs which actually work with variance without actually like trying to solve it. But I guess we could go something like this, and then, well, okay. Here, this digit would be a 7 because it sees only 7 digits that are shaded. Yeah, it's hard to come up with a yin yang. Okay, say this went something like, I don't know, this. This would be 3 digits because it only sees 3 digits vertically and horizontally. This would also be 3, right? Because it sees only 3 digits horizontally and vertically. And remember, the digit in the upper left-hand corner sums up all the digits that are seen. So that should tell you actually quite a bit of information. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is actually the most interesting, right? Because the sum of the digits seen add up to 5. Therefore, seen vertically and horizontally is 5. It can't be 1, because again, it must see, every one of these digits have to be at least 2, right? Because it has to be connected orthogonally to the rest of the cells of its region. So this is 2 or 3 here, because it can't be 4. If you have 4 digits that it sees, one has to be a combination of 1 and 2. So 4 plus 1 and 2 already adds up to 7, which is not allowed. So this is 2 or 3. It could see 3 in this way. This could be 1, 1, 1, 1, 1, and 3. Or it could be 2, and then it sees 3 somewhere else. But one of these cells, then, has to be the opposite shading. Oh, and we don't have a difference between what's shaded and what's unshaded. So we can just choose, essentially, this to be shaded or unshaded. To add up to 45. Now that's interesting. What's the minimum? Obviously, you can have up to 9, but what's the minimum amount to add up to 45? You have essentially the lowest digit in the middle, and then a 9 and an 8 in both directions. So 9, 8, 9, 8, 7. So that's 17 on either side. But you would see 5 digits. So it would be 5, actually. 5 plus 8, 9 plus 8, 9 is 17 times 2, 34 plus 5 is 39. So to see 5 digits, you cannot add up to 40. You can't add up to 30. You can only add up to 39. To see 6 digits, though, works because you have 7, 8, 9 maximum, which is 24, plus 17, and then you have 6 added on. So you would have 6, 7, 8, 9, or 6 with 8 and 9 on both sides. So it's 17 times 2, which is 34. 34 plus 6, and then you would have a 5. So you could have... So anything adding up to greater than 39 has to be at least 6 digits that it sees. To be at least 39. So this is at least 6 digits that it sees. Let's see. To add up to 30... let's see. Can you have... What does 4 add up to? 4 would add up to, at most, 8 and 9 plus 9. So 8 and 9, 17 plus 9 is 26, plus 4 is 30. So this could be 4 through 9. 33 would be 5 through 9. 26, if you have 3, you cannot do that. 3 adds up to, at most, 3 plus 9 plus 9, and that's, well, 3 plus 9 plus 9. And that would be 18 plus 3, which is 21. So this is 4 through 9. This is also 4 through 9, and this could be, you can't be 2. So it's 3 through 9 here. Okay. Can this be different? I guess? Can they... what happens if they're the same? Is kind of a question too, right? If they're the same... So say they were the same. So if these are the same shading, the problem is the set of digits they see here are the same. And they add up to less than 45, because if they were both 45, these would be exactly the same digit, right? So these add up to less than 45, so both of these must be going see something this way. And if they both see something this way, this becomes a 2 by 2 of the same shaded cell. So one of these is shaded one way, and the other one's shaded the other way. So we'll make this green, we'll make this blue. We have to have a different shading here then. So that means going this way, this must be green. This has to be at least 6. So it has to go at least here. This must be at least 6, so it could just go here. Technically, this doesn't have to be green, right? And this doesn't even have to be green. But on yin-yang shading, once you swap to the other side, you cannot swap back. So if this were, first of all, this can't be all the same shading here, right? If this is all the same shading, this would see 9 and would add up to 45. So this must change somewhere along this one. Therefore, this is all the same. This has to go this way, which means it has to go at least this way then. Because this is all the same shading. It swaps here because this 46 needs to be able to see more than that. Because to add up to 46, it needs a different digit. So it has to go to here. It could just be 1. So if this is green, it will block the blue out from being in this area. And we know, okay, so first of all, we know this is blue because this is a 2x2 area that doesn't have, that is all green. This is a 2x2. Well, we don't, this is, well, we don't know about that. So this has to be blue. This blue has to get out. If this is green, that fails. Right, so the blue cannot go out and orthogonally connect to the rest of the blues. So this must be a blue. So it must be blue, blue. It has to connect this way to the blue. This has to be green. This must be green, and this must be green. This must be green also because of the 2x2 area. This is at least 6, so that satisfies that. This green must see at least 6. And it cannot see all, though. This is blue. If it's 6, it could be 9. Okay, this has to extend further. Well, it doesn't have to extend that way. It could extend this way. We know this is a boundary. We know this is boundary. This is boundary. This is boundary. And this is boundary. I guess this... Okay, no, this can't be... This it does have to change here. So this has to be green here. And this must be blue. This could be blue. Right? It could extend here. That's fine. Can this be green? I guess so, if it stops there. Hmm. This could be green. Actually, can this ever be blue is kind of a question, right? This cannot be blue. Well, if it goes that way. Maybe. Oh, how is this ever... well, So this can never fully go this way and this way, right? it's blocked. This is at most 6 digits, and they have to be unique, adding up to 43, which is not going to work. This is at most 7 digits, which add up to 43, but that doesn't add up because they're unique. So it has to go both this way and this way, which means this has to be a blue. That's interesting. Because of the 2x2 area. Let's not make it black, actually. Let's make it red. So that we can more easily see these. Okay. We have that, we have that. This is separate, this is separate. This is separate. Okay, so this has to be, if it's 3, I guess that's possible, right? Even if it's 2, it blocks off the other way, right? So it goes either here then here, or here then here. So can this ever work blocking off this way? You have 9 at most, and then 6 digits. 6 digits plus... So this can never be 9, because this goes only 2, and then goes another direction. Or 3, and 3 cannot be in the same direction, so it would have to go 3 that way, and then go in that direction. And then block this off. So this is either sees 7. I guess it still could see 6, technically. Can it? 6 with 9 is 15. And 43 minus 15 is 4, 7, 8, 9. Could work. Yeah, so it could be 6 still. It cannot be 9 ever, though. Because it's at most 1. Well, it has to be 1 within the next direction, right? So it could be 1 with these 7, 1 with these 6, and those are the only possibilities. And then you could have 1 and 5 would have to be that way then, if you went that way. This is 2 and 3. Again, it could just stop here and then connect that way. It has to connect somehow, and it cannot connect to... It could connect this... Okay, it could connect this way. Never mind, this still could be 9. So it could connect this way some way. It doesn't have to connect that way. This has to be greater than just 6, because if it's just these 6, obviously those 6 never add up to 45 by themselves. So this has to be blue, which means this is blocked this way. So this is at least 6. So this one then... Okay, so this has to be green, because of this 2x2 area being all shaded. This is at most 1, 2, 3, 4, so we need at least another 2. So this is green, which forces that to be blocked. The blue could go here. You don't know how this works. So this is at least 7 digits that it sees. This can't be 6. If this were 6 specifically, how does that work? It has to... These 5 digits are at minimum 5, 7, 8, 9. So this would be 6 plus 5, 7, 8, 9. Sorry, maximum 5, 7, 8, 9. So that would be 35, and this digit would have to be 10. So this has to be at least 7, which forces this to be a green here. So this is green. That means this is a boundary. Oh, that's interesting. I think this almost certainly has to be blue. We have one digit, which can be repeated here. What's the so say this was 9. What's the minimum amount we could have in this direction? 9, 45 minus 9 is 36. That would mean that you have to have at least 98761. So that's at least 7. So this has to be at least 7 in this direction. So this is green. Sorry, blue, which means this has to be green shading. All of these are green, so this must be blue. To connect to this, we need a blue here. Therefore, this has to be green, because otherwise this 2x2 area would be all blue. So we have this area all set. This cannot be blue, because if it's blue, it would cut this green section into multiple sections. So this must be green. Oops, not red. This is green. So this sees 8 at least. This sees 8 exactly. 1, 2, 3, 4, 5, 6, 7, 8. So this sees 8. Let's see. This cannot be 8. This cannot be 8. This sees at least 6 because it sees 6 that way. Okay. Can you ever see 9 with to add up to 24 is kind of a question, right? What's the minimum sum you could have if you have 9 digits? You could have 9, 1, 2 going one way and 1, 2 going. So you have 1, 2, 3, 4 going one way and 1, 2, 3, 4 going the other way. So that would be 29 is the minimum for 9. So this can't be 9. 29. 8 could work. 1, 2, 3, 4, and 1, 2, 3. So that's 16 plus 8 is 24. So 8 could work, but this can't be 8 because of the 8 in the row. So this can't be 8 or 9. What about 7? 7 could have 1, 2, 3, and 1, 2, 3 add up. That's 6 and 6. 12 plus 7 is 19. So this can't be 7. 6, I think, does work. 1, 2, 3 plus 1, 2 on the other side. 1, 2, 3 plus 1, 2. That's 6 plus 3, which is 9, 15. Yep. So you would have 1, 2, 3 plus 1, 3 essentially, or 1, 2, 4 plus 1, 3 possibly on that side. Okay. You have 8. You have 8 digits in total. So what's the minimum this digit could be? Even if you have 3 through 9, that's 42. This has to be at least 4. So this is 4, 5, 6, 7, or 9. What's the what values have to be on this one? If we have 9 and 8. Oh, so if you subtract 9 from this, 9 from 46 is 37. That means the digit 9 has to be in one of these cells, right? Because if it isn't, it will not be able to... Say you take the largest 7 then, after without a 9. You have 2, 3, 4, 5, 6, 7, 8. That would be 35. 35 plus 9 obviously does not add up to 46. That's up to 44. But if you had a 9, then you could have 2, 3, 4, 5, 6, 8, 9 without a 7. Can you actually ever have a 7 here? Is kind of a question. Because you're missing an 8 or a 9 here, specifically. I don't think you can have a 7 here. If you have 7, just 7 here, this is at most 9. Say this was an 8. Then this would be, at most, 3, 4, 5, 6, 7, 9. 3, 7 add up to 10. 4, 6 add up to 10. 5 and 9, so that's 20. 5 and 9 add up to 14, so that's 34. Plus 9 does not add up to 45. So this has to be an 8, also 8 or 9 also, which makes this blue also. Interesting. That leaves this as blocked. So we have an 8, 9, 8, 9 pair, which eliminates 8 and 9 in the rest of the row. So one of them has to be 9, and the other one has to be 8. That's interesting. This has to also be 1 through 7. Can you have in this direction, though, again, without a 7 in this row? I think so, right? That would mean the most for 7 digits would be 2, 3, 4, 5, 6, 8, and 9. 2 and 8 add up to 10. 4 and 6 add up to 10. So it's 20. 3, 5, 9. Basically, it's subtracting out 1 and 7. So 45 minus 1 and 7 would be minus 8, so it's 37. So you have 37, and then plus 9 would add up to 46. So you could be without a 7 here. So that's fine. If this is 8, this could be 6, 7, or 9. 4, 5, 6, 7, 8, 9. So this cannot be 9. Because if we tried to make it 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, then it would have to be 10. If we try to make it 9 this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, again, it would have to be 10. So this can't be 9. This is 6, 7, or 8. Okay. Kind of the question here then is, what are these digits here? So this adds up to 45. This adds up to 45. I think this is more likely to be 8, but we don't have a rationale for that. It's just a gut feeling. I feel like this is more likely to be an 8. If this is blue, that means both of these are green. So this would only see... I guess you could still have 4 digits. And then, no, you can't have 4. It would have to be at least 5. Could it be 6? No, because if it's 6, then these would all be blue. And this would have to add up to 30 because you don't have anything in the horizontal direction. and this adds up to 26, but this already adds up to 30, so that's not possible. So if it goes this way, it has to be specifically 5, because 4 digits with 4 in it does not add up to 30. So that's possible. If this were green, the problem is this 2x2 area would all be green. So this would force this to be blue, but you still have to connect to here to get orthogonally connected. So it would extend it further here, so this would be green. So this cannot be green. This then has to be blue, right? So again, the logic here is that this is green, this 2x2 area has all greens in it, so it needs a blue here. This green still needs to connect to the rest of the region, so this would have to be green, and therefore this would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, and that's not allowed. So this cannot be green, this has to be blue. Which means this is a boundary. So this sees 8. 8 digits, this sees 9. So this would see 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is blue. So this is blocked. This sees at least 6. It could be 7 or 9. We don't know. This sees 8 digits that add up to 45. That's interesting. It's almost guaranteed that you have a 9 here. So this is 9, therefore this must be green here. So this cannot be 6. It has to be at least 7 then. Because this must be blocked off here to see only 9 digits. This sees at least 7. If it sees, can it be 9? It could be 9. But with 9 and 8, if you see 9, so that would be 9, 8 with minimum 1, 2, 3, 4. That would be 17 plus 17 plus 10. That's 27. I guess it could be 1, 2, 3. So it is possible, right, to add up to 33 as 7 or 9. It would have to be 1, 2, 3, 4. But then does this ever add up to 45 if that's the case? If you have 1, 2, 3, 4, 9, 8, this adds up to 27. This adds up to at most 6 and 7. So this cannot be 9. This has to be 7. Also, we know this is blue, but we know this is blocked off here. And this has to be essentially that. So this is blue because of this 2x2 area being all green. Therefore, if this were green, that would cut this blue into 2 separate regions. Because it would have to surround this way. This is blue also. So these have to be blue. These are all blue. This is blue. Okay, that's interesting. So this cannot be blue. If this were blue, that would force this to be green, but this would have to be 30 to add up to 30. This is a 2x2 area. This must be green. So this has to be a green. This must connect here to connect through. This has to connect through. Otherwise, it won't be able to be orthogonally connected to the rest of the green cells. This is blocked here. This is at least 5. So this is 7. This cannot be 7. This can't be 7 either. 1, 2, 3, 4, 5, 6, 7 at most, so this can't be 8. This sees at least 5, and it could see up to 8, so this can't be 9. This sees 3, so this is 3 here. To add up to 16, and they're 2 unique digits. Okay, so this is at most 8, which means this is this is 11 at most here. This must be 5 at least. 5, 6, or 9. To add up to 16, these 2 digits must add up to 13. So 4, 9, 5, 8, or 6, 7. So this sees 3. These 3 digits are blue, so this must be a green because of the 2 by 2 area. One of these is green, one of these is blue. Because this green has to go out, cannot be both green because it would be 2 by 2 area of all green. Yeah, but it has to go connect. So one of them must be green. If it's green that way, this is blue. That's fine. If it's green this way, this is blue. And then this has to be green that way. Okay. Can this ever be... Okay, so if this is green here and this is blue, this blue must go out this way. So say this was green. This becomes blue because of the 2 by 2 area. This green must connect to the rest. This blue must connect to the rest, but it cannot go further than just 2. So it has to go this way and then this blue, but then this would basically be blocked. This green area would be another region as this green area. So this is not possible. Therefore, this must be green, which forces this to be blue. Since this is blue this way, it has to connect to the blue. In other ways, this is a 2 by 2 area that's blue, so this must be green. Therefore, this sees 2. And this must be 3 to add up to 5. So these are region boundaries. This obviously can't be 3 anymore. These can't be 2. This sees 1, 2, 3, 4, 5. So this is 5. These 2 by 2 areas blue, so this must be green, which forces this to be green because otherwise you'd be separating out the green areas. So this is green. This must be blue then because of the 2 by 2 area. This must be green then because of the 2 by 2 area, which forces this to be green to be connected orthogonally. This 2 by 2 area is all green so far, so this must be blue. This is green. It sees 1, 2, 3, 4, 5, 6. So this is just 6 then. 6 cannot be here. To add up to 43, you need... You have at minimum 8, 9 on one side. So that would be 6, 8, 9. This 6 cannot be 6 here. This sees 4 at least. It could be more. Wait, we don't know if this is region. I don't know why that had that. Anyways. To add up to 43, you have 6, 8, and 9 max on one side. That's 23. So that would leave 19 on the other side? No, 20 on the other side. Without a 6. You could have 5, 7, 8. That is possible. This 5 eliminates 5 here, so this is at least 6. So this green must go this way, which means this can't be green because of the 2 by 2 area. So this is blue. this cannot be 7 ever, because if it's just 7, it would extend 1, 2, 3, 4, 5, 6, 7, and it would have to connect to 8. So this is 6 or 8 here. This sees 5, and it adds up to 26. If you had 8 here, that means the 7 digits you would have there at minimum would be 1, 2, 3, 4, 5, 6, 8. Therefore, this would be 1. That's possible. Hmm. What's the minimum amount here? So again, the maximum here is 6, 8, 9. That means this adds up to 23 if it's the maximum. So these three would have to add up to at least 20. So that would be 3, 8, and 9 is possible, but 3 cannot be here. 9 cannot be here. So if this were 3 here, the problem is this would be 3, 7, 8 maximum, and that's not allowed. So this can't be 3. You could have a 4 here. It's 4, 8, and 9. Or 4, 7, 9 works. 4, 7, 8 does not, so this can't be 4. This can't be 6, obviously. This can't be 5 because there's a 5 in the column. What's the maximum here? It's 6, 7, 8, and 9. So that's 30 for 4 digits. That would mean these 2 digits add up to 13 at least. So it has to be 4 and 9, and it cannot have a 6 either. This can't be 5 because of the 5 here. One of these two. Okay. Yeah, this actually has to connect here. Because otherwise the green area is not connected at all. So this has to be connected. One of these two is green. One of these is blue. We're not sure which is which. So this is 8. That means the minimum amount of these digits would have to be 8 plus 1, 2, 3, 4, 5, 6, which is 29. And that plus 1 adds up to the 30 that it has to add up to. And that's the minimum, period. So this has to be 1, and these must be 1 through 6 here. But again, we could remove 1 and 3 here because of the 1 and 3 in the box. This has to be a 7, 9 pair on the outside. This can't be 6 because of the 6 already in the column. This can't be 2 because of the 2 in the column. 3 has to be one of these 2 digits. That's interesting. This 8 eliminates 8 here. So we have 3 and 5 already in this 5x sum, internal x sum. That adds up to 8. 26 minus 8 is 18. So the other 3 digits must add up to 18. Okay, this can't be 1. This is at maximum a 6. Okay. Obviously, it could be 1, 2, 4, and 6. And what does that mean for this sum? So we're guaranteed to have 4 or 7 here. If this is 4, well, you could have 8, 9 here, or 7, 9 here, but it has to be 9 here, essentially. If you have 7, you could have 8 and 9 here. And that's possible, so... I don't think this can ever be 4, though. If this were 4, this would be 9, so this would be 13. This would then have to be 6, 7, 8, 9, and this 4 would eliminate... This 4 would force a 9 to be here, which would eliminate 9 here. Therefore, this would not have a 9 here. So this cannot be 4. This is 7, 8, or 9. This is at least 1. Can you ever not have a 9 here is the question. The maximum without a 9 would be 3, 4, 5, 6, 7, 8. 3, 7 adds up to 10. 4, 6 adds up to 10. 5, 8 adds up to 13. So that's 33. Oh, you can't have 33 here. You have to have at most 32. Because this is 1 digit at least, and so at least 1. So this adds up to 32 at most. Which means these 2 digits must add up to 13, and you have to add up to 13. So this must be 6 and 7, which eliminates 6 and 7 in the rest of the box. This then must add up to 32, right? Because 32 plus 13 adds up to the maximum of 45. This is at maximum 32. So since this is maximum 32, this is minimum 13. Therefore, we know this is 32 plus 13 to add up to 45. So this can't be 6 or 7 here. 1, 2, 3, 4, 5. 3 has to be one of those. 3 is here. We know both 2 and 3 are here. This must add up to 32, which makes this a 1. So these 3 must add up to 13. Okay, it's possible. Yeah. 8 then has to be one of these 2. We're not sure in column. 2. Okay, so this cannot have a 6 or a 7 at least here. So this is, say you had 1 and 6 here. That would leave this as a maximum of 45 minus 1 and 6, which is 7. So that's 38. This is 38 in maximum. This has to be a 9 then. So we know this is 9. That means this adds up to 46 minus 9, which is 37. If this is 37, so we know this adds up to 32, so this is 13. If this is 37, that means, okay, so this cannot be 5 because it sees, if it tried to see 5 only, it would see another one. So this is 4 or 6. This adds up to 37 again, because 46 minus 9 is 37. That means these two add up to 45 minus 37, which is 8. So this has to be 1 or 2 to add up with the 6 or 7 here. 3 has to be one of these two. We're not sure which. This cannot be 5 because of the 5 in the column. These digits in row 5 have to be 2, 3, 4, 5, 6. And 5 cannot be either of these. So 5 has to be one of these two here. This does not have a 1. So again, we have to have a 3 here. So this can't be 3. Cannot be 3. And this can't be 6. If this is 4 and 6, that does kind of work, as this could be 5, 9, or 6, 8, possibly. What else do we have? So this is 26 here, which means these 4 add up to 19, because 45 minus 26 is 19. Does that tell us anything? Not particularly. One of these is green, one of these is blue. We're not sure which is which. The green because you have to connect the green, the blue because otherwise it would be a 2x2 area with all green if they were both green, so that can't be the case. This again adds up to 13, but we don't know what that really gives us. If it's 6, what's the minimum for these 5 digits? It would be no 2. So it's 5 digits here. 1, 3, 4, 5, 6. That would be 3 and 6, 4 and 5, and 1. So that's 9 times 2, which is 18 plus 1, 19. So it could add up to this. If it were... Wait, could it? Oh, you can't have 1, 3, 4, 5. So say this was 6. You can't have 1, 3, 4, 5, 6. If this is 4, can this ever be 2? I don't think so, right? If this is 4 and 2, that means these two add up to 6. 24 minus 6 is 18, and these two digits would have to add up to 18, which is impossible. So this cannot be 4 and 2. If this is 4, that means 6 has to be here. Otherwise, this is 6. So 6 can never be in the rest of the row, because the 4 requires the 6 to be with it, to be 5 and 9 or 6 and 8, to add up to 24 total. If this is 6, can it ever be 2? I think so, right? In fact, I think it has to be 2. I think 6 and 4 doesn't work. If this is 6 and this is 4, those add up to 10. So the other 4 digits would have to add up to 14. Okay, wait, that works, I think. Right, 1, 3, no. You don't have a 2. So if you had a 4, so 6 and 4, the other 4 digits would add up to 14. But, so you have to have 1. But 3, 4, 5 doesn't work because this is 1, 3, 4, 5, and that would eliminate all if you had a 1, 3, 4, 5 quadruplet, that would eliminate 1, 3, 4, 5. And that's it only adds up to 13 anyways. So if you had... So okay, if this is 4, this is 6. That's 10. This has to be added up to 14. So this would then be 5 and 9 or a 6-8 pair, which is possible. If this is 6, that means all of these are seen. 6 and 4 add up to 10. but you don't have any combination of 4 unique digits to add up to 14, right? You're missing a 2, you're missing a 6. You need 4 digits to add up to 14. You have a 1. 1, 3, 4, 5 unfortunately adds up to 13. 1, 3, 4, 7 adds up to 15. And then if you try any 1, 4, 5, 1, 4, 5, 7 already adds up to 17. So I don't think you can have a 6, 4 here. Can you have a 6, 2 here? Maybe? If you have 6 and 2, that's 8. 24 minus 8 is 16. Yeah, that seems doable. Oh. This can't be 5 anyway here. So because this can't be 5, this would actually have to be a 6 anyways. So 6 is always one of these 3 digits, right? Because either this is 6, in which case obviously it's a 6, or this is 4, 6, which would force us to add up to 14 because the 4 sees only 4 digits that are the same shading. So it would be blocked off here. So 6 always has to be one of these, so this can't be 6 here. Again, if you try to have 6 and 2, how does that work there? 6 and 2. So you have 16, right? You need to add up to 16 without a 6 or 2 possible. Could you have a 9? No. 1, 3, 4, 9 adds up to a minimum of 17. So you could have any other possible combination. That's not good. There's no 5. Well, 5 could be here. We just know you can't have a 9. Can you not have a 9 here? Then you have 5, 7, 8 at minimum, or maximum, sorry. 5, 7, 8 at maximum. That would leave to 20, and this would be 6, 8, 9. So yes, you could do that. Okay. Okay. So 6 has to be one of these 3s. Therefore, 6 in column 9 must be one of these 2. Because this can't be 6 because of 6 in the box. This 6 eliminates 6 here. 2 has to be one of these 2 here. Okay, this is 15. So we have 15 here. That means this has to add up to 30. To add up to 45. Therefore, this must be 6, 7, 8, 9. Okay. Can't be 9. This can't be 6. This 6, 7, 8, 9 eliminates 6, 7, 8, 9 in the rest of the column. So this has to be 4, which makes this 4 and 9, adding up to 16. This can't be 4, 6. This becomes a 2, 5 pair, which eliminates 2 and 5 in the rest of the box here. This 4 eliminates 4 here. Again, so these add up to 26. These add up to 4. Sorry, 5. So that's 31. These 2 then must add up to 14. Cannot be 2 then. This has to be 6, which makes this a 4. So this must be then a 6, 8 pair here. Because it cannot have a 5. Can't be 5, 9. So this is 6, 8. This is 6. This must be 6 and 8, right? To add up to 45 minus 31, which is 14. Yeah, so this is 6 and 8, which forces this to be 6, which makes that an 8. This can't be 6 or 8, so it's a 7, which makes this 8, which makes this 6. This 8 eliminates 8 here. we need to have a 9 here. Otherwise, this is 4, 5, 7 at minimum. And that doesn't add up enough to add up with this. So this must be 9. This can't be 8 or 7, so this is 9 also. So it can't have 9 here. This must be 7, at least here. And it could be 4 and 7 or 5 and 7 here. We don't know which. This can't be 9, so this has to be 9 here. So this makes this a 3. This can't be 3 or 4. It's a 2, 5 pair here. This is 4, 7, 9 or 5, 7, 9. So that's 21 or 20. This must be then 23 or 22. So this is 7 or 8 here. We know the 7 has to be here. This is 6, this is 6. 2, 5 pair. This has to be a 2. Yeah, that's the only digit remaining, so let's just double check. 7 and 3 add up to 10. 2 and 9 add up to 11, plus 5 is 16, plus 10 is 26, so that works. This is 2 and 3, that's fine. This is 4, so it does not, it blocks there. So this has to be blue. It's not green, and this is not blue. Okay. 4, 6, 8, 9. The remaining digits in box 6 are 1, 3, and 7. And this can't be 7. So 7 is one of those two. This is 9. So again, this adds up to 32. This must add up to 13. So it must be specifically 1 and 3 here. Which eliminates 1 and 3 in the box and 1 and 3 in the row. So this cannot be 3. Therefore, this must be a 3 here. This must be 2, 4, 5, 6, 7. Or 2, 4, 5, 6 as the remaining digits here. This can't be 2 or 6. This can't be 2. This can't be 6. This can't be 5. This can't be 4 here. And this can't be 6. We need a 6 in the column. 6 can't be either of these or this, so this must be a 6 here. This is 1, 2, 4, 5, or cannot be 7. So it's 1, 2, 4, 5. This becomes a 7, 8, 7, 8 pair, because those are the only possibilities there. This can't be 2. This has to be 1, 4, or 5. We already knew 2 was one of those two anyways. This can't be 9, whereas the 9 in box 1 has to be here. So this is 9, which forces this to be 7, which forces this to be 9. This is 1, 4, or 5 here. This cannot be... In column 5, what are the remaining digits? We have 2, 4, 6, and 7. 6 can't be here. This becomes a 2, 4, 7 triplet, which eliminates 2, 4, and 7 in the rest of the box. Actually, this can't be 7. So it's a 2, 4 pair, which eliminates 2, 4 in the rest of the box. Well, this can't be 2, actually, because this... So this is... what are the possibilities? Okay, this is a 7, 8 pair, because 7 has to be one of these two, so this can't be 7. And 8 has to be here. That forces this to be a 1, 4, 5 pair. Cannot be 1 or 5, so this is a 4. Which makes this 5, which makes this 2, which makes this 4. That leaves this as a 7, and this is 5. So this is 5, 7, 9, 21. These three digits must add up to 22, so it's 6, 7, and 9. Which makes this 8. This can't be 4 or 5, so this is 1. This can't be 1, so this is 2. This can't be 4 or 5, so this is 1. This 4 eliminates 4 here, so that's 2. This can't be 2, 4, or 5, so this is 1. This 2 and 6 add up to 8 to make sure that this adds up to 37 here. This is 7. 1 cannot be any of these. Actually, 1 can't be here either. So this is 3, this is 7, this is 1. This cannot be 4. This cannot be 4. This can't be 3. This can't be 1. This can't be 6, so this must be 4. Remaining digits in column 6 are 7 and 9. This can't be 9, so this must be 7, which makes this 9. This digit is 1, 2, 3, 4, 5, 6, so this has to be 6, which means this can't be 6 here. So that forces 6 to be there. Where is the 6 in row 8? It has to be here. What else do we have? Yeah, everything else is just normal Sudoku. So this must be a 1-4 pair. This can't be 1 because of 1 in the column. So this is 4. This is 1. In row 6, we have 3 and 5 remaining. This can't be 3 because of the 3 in the column. So this is 5. This is 3. This is a 2-8 pair in column 2. In column 1, we have a 4-5 pair. Okay. We need a 7 in column 7. 7 cannot be here, here, or here, so this must be a 7 here. This is cannot be 1 or 3, so this must be 5 in here. That eliminates 5 here, so it's 4. This is 5, which makes this 2, and 5. 2 eliminates 2 here, so that's 8 and 2, which forces this to be 8. This can't be 5 here, so this is 3, which makes this 1. That makes this 3, which makes that 1. This can't be 3, 4, 5, so this is 2, which makes this 5, which makes that 2. This can't be 3 or 5, so this is 4, which makes that 5. That leaves this as a 4 and this as a 3. And that's the solution. Yeah, I was a little slow here, I must say. I don't know why, actually. I just was kind of slow today. Anyways, I like these type of puzzles, though. They're fun for me. And I hope you had a good time watching this solve, and I'll see you next time on Frank Puzzles. Take care.